Hello, everyone. Welcome to this afternoon's webinar. This is a little bit of a different time frame than we normally have for Cal Geo webinars. That, of course, is because we are joining to co-sponsor this with ACE Mentor. We have two people from ACE Mentor on right now. So we have Paulette Dallas, and then we have Michelle Porter as well. We'll be having them say a word about ACE in just a second here. Today's webinar actually a tour that maybe some of you went on with us this last fall. We went in actually down to Carson to look at the site where the tunneling starts. And so Maria Rosales Ramirez, she was the one who gave us the part of the tour then and did the presentation. This is going to show a little additional video of the tunneling and what's going on with the project, show the status of the project. It's a really interesting project because it's 7 miles long, it's costing $700 million. And the tunneling machine that they're using is just massive. So it's a pretty interesting project. I do want to introduce Maria very quickly. Before I do that, I do want to remind you that our numerical modeling panel that's coming up, the last day to register at early registration pricing is today. Our conference regular registration pricing ends Friday. So if you have not done that, please register ASAP and save yourself a little bit of money. With that introduction of Maria Rosales Ramirez is a senior engineer in the Public Information Office of the Los Angeles County Sanitation Districts and a board certified civil environmental engineer with the state of California. After her postgraduate work, Maria joined the sanitation districts in its solid waste management department, focusing on landfill gas research and later on landfill disposal capacity and recycling projects. So currently she is working in public relations at the department, and a lot of what she does in relation to us at least has to do with this project in particular. That's where we are intersecting with her public relations work towards us. So you will get to meet Maria in depth here. You'll be able to ask her a lot of questions. I do want Paulette and Michelle, though, to go ahead and introduce ACE Mentor very quickly. They're going to tell you what you can do if you want to get further involved with ACE Mentor in your area, because there are several sections here in California with which you can get involved. Paulette, take it away.
Thanks, Nick. Thank you so much. And thank you for having us today. Thank you for joining this webinar. We're very excited about it. ACE has been around for about 30 years. If you are here and you are a mentee or a mentor, or you would like to get more involved, I will drop a link in the chat just a little bit. We are a high school mentoring organization. We are, workforce development. We are helping get kids excited about the industry. I'm happy to answer any questions about ACE afterwards. Like I said, I will put my information in the chat. Michelle is on. She's our curriculum person, and she is very excited also because we will be using, we love these kind of webinars and virtual field trips so we can share out to our students across the country. Here in California, where Cal Geo is based, we do have 5 different ACE affiliates covering the entire state. We recently just opened up a team in Fresno, San Luis Obispo, and so we're kind of covering the entire state. So if anybody was interested in getting involved, please reach out to us. And with that, I would like to turn it over to Maria for the fun part of this webinar. Thank you.
Hi, everybody. Thank you so much for the opportunity to be here. My name is Maria Rosales Ramirez with the LA County Sanitation Districts, and I'm here to talk to you guys about the Clearwater project, which is a project that I've been working on for the past 5 years. And actually, it's been a multi-decade long project for the sanitation district. So this is a great opportunity to highlight the work that we do. So just to start off, I realize that many of you may not realize who are the sanitation districts of Los Angeles County. So let's get a little bit on that. So the Los Angeles County Sanitation Districts are special districts that specifically dedicated to managing the wastewater and the solid waste management needs for LA County. So we're not LA County, we're not the city of LA, we serve LA County. And what you see here is our service area highlighted in white. We have over 78 cities within LA County and 5.5 million people in our service area. So I can say with confidence we serve half of LA County. Over 850 square miles is our territory. Now, how do we serve them? Our service is to manage their wastewater, their sewage. And what you're seeing here is our network of water reclamation plants where we collect the sewage and we end up recycling the water in our water reclamation plants, which you see highlighted in yellow. We have them all over our service area. But the highlight of today's presentation is the Warren facility, which is right here in the lower part of LA County, if you're familiar. You would see it's the one closest to the lower part, the Warren facility. This facility is quite unique because it does so much for LA County, just in terms of the services that we're able to provide. So I don't know if any of you are local. For those of you that were visiting on site, we met here. If you're driving down the 110 freeway, just past the Clearwater, you're able to pull over and see it. But this facility is the largest water treatment plant for Los Angeles Sanitation District, meaning we can receive up to 400 million gallons of wastewater a day. And what we're seeing video, I'll replay the video a little bit again so you can see is the different treatment processes that we have right here. We're going over our primary and secondary treatment. Again, we use standard processes to clean the water, and that's kind of what we're seeing right here, our secondary treatment plants. But also we have so many other facilities ancillary to the wastewater treatment system. And this is our solids management. We're going to kind of cover that in a little bit. And we have our power plant. And if any of you have heard of the Pure Water Demonstration Facility, this is another regional recycled water project. And this facility in Carson, the Warren facility, is the hub for that, the starting point for that. So I can say in all confidence that this facility is essential to the work that we provide for LA County. And what I'm showing you here is a footprint of our facility and how at its core, we convert waste into resources at this facility. So starting from the right side, going forward, because of our wastewater treatment facilities, we are able to have a facility on site that produces up to 20 megawatts of electricity. So that's enough power for 20,000 homes. We also do food waste recycling here in the state of California and in LA County. We have to collect our organics, our food waste scraps, and we recycle that. So that's also what happens here. In the future with water recycling, with the Pure Water project, this would be the starting point for that. And this would be water for 1.5 million people in LA County in the future. And we also do solids recycling. So anything that comes into our wastewater system at this facility will get recycled at some point. So that's certainly exciting. But that's not the topic of today's presentation. That's a separate presentation that I'd be very happy to be if anybody's interested. The subject of this presentation is what happens to the water after it leaves the Warren facility. And for those of you familiar to this area, they will say, well, you manage the water and you recycle the water, but where does the water go? Carson is 7 miles away from the ocean, as we can see in this map right here. So you're right. The Warren facility is 7 miles away from the facility, and this facility was built in 1928. Back then, 1937, we built a tunnel that would take the clean water from the Warren facility out to the ocean in Royal Palm Beach, and that's the tunnel that we see, the 8-foot tunnel that we see that was built in 1937. Later on, as the limits, the facility was taking on more water because LA County kept on growing, we had to add an additional tunnel, a 12-foot tunnel, that's the one on the left, that was built in 1958. And that's how the Warren facility is able to clean the water and take it out to the ocean. We have these 2 tunnels. And so for us, knowing how much the Warren facility does for LA County, it's imperative that we're able to kind of think long-term. Does the Warren facility have all the resources to keep operating well into the future? And one of the things we identified was that having 2 tunnels, it's not ideal. We need some redundancy here. So let's explore why. Well, the first thing is that this is aging infrastructure. These 2 tunnels were built in 1937 and 1958. And because of the volume of water that we produce, these tunnels have been working every day since they were put into operation. So we have no way of being able to inspect them. We also tried the high-tech approach of putting an underwater drone to be able to monitor them. And that did not work well because the water is too fast and there's quite a bit of a drop in there. So that didn't work out too well. The second reason is seismic concern. So these tunnels were built in 1937, 1958, well before there were standard seismic considerations that were pulled into place. And it does cross at least one active fault, the Palos Verdes fault line. So obviously that's an area of concern. If you guys remember earlier, maybe late last year, there were quite a series of earthquakes happening close by. So that's definitely something we need to address. Let's make sure that we have something that's more seismic proof in this area. And the last reason that we want to build a new tunnel is that not many people know, but here in Southern California, we have we are in charge of the sewers, but sometimes when it rains and in periods of heavy rain, all the water that comes down into the streets that would go down into the storm drains can actually get input into the sewer system, which means it comes down to our facility. And because our system of wastewater treatment plants is connected, that means that the Warren facility is able to gather, collect water quite a lot. And that means the plant is at risk of overflooding during major storm events. For those of you that are local to California, almost a year ago was the time of the atmospheric river where we had some few days with high intensity rain for quite a long time. So at that time, our flows almost tripled. And that means that the tunnels, the two tunnels, need to be able to push this water out, and if not, the water can back into the Warren facility. And as I mentioned earlier, this facility is too critical for LA County. 5.5 million people depend on it, so we can't let this facility flood. So for all these reasons, we are building a new tunnel, which is the Clearwater tunnel. This is key to the Clearwater project. Let's build a new tunnel to take the water from Warren out to the outfalls in Royal Palms Beach. So the old days of making tunnels. So these are actual photographs from when our tunnels were built back in 1958 and 1938. And back then, the land uses were very different from what we have now. We used to be oil fields. The cities weren't as populated. There was lots of open space. So it was easy for us to trench our way across, drop our tunnel in as we see here, and then cover it up. That's not necessarily the way we build a tunnel now. For one, we have population and environmental considerations. We don't want this. We want this to be as the least disruptive process that's possible. So what is the alternative? The modern way of making a tunnel is the use of a tunnel boring machine, which is what we're showing you here. And this isn't our tunnel boring machine, but this is an example of a tunnel boring machine, which is, it's a magnificent piece of technology because it's able to do multiple things at once, and I'll kind of walk through it. It's able to dig the tunnel, build the walls of the tunnel, and move the soil above ground. So it's very efficient, it's the least disruptive, and it's able to help us finish our tunnel faster. So let's learn a little bit more about that. How does the tunnel boring machine work? So here we have kind of a video kind of showing how it works. We see that part in orange is what we call the head of the tunnel boring machine. It actually spins and cuts away at the soil. Now, once it spins, it usually moves around every 5 feet. It pushes itself off the truss jacks, which is what you're able to see right here. And as it does that, each truss jack is able to move independently to create space to put blocks of the walls. Each little wall is a little segment. So you can think of it as like a Lego. Each part of the wall is a little ring. Together, 6 rings make up the walls of the tunnel. And also, I'll play the video again so you can see it. So this is right now cutting the soil away. I like to think of it as a cheese grater. Now you see the arms kind of moving, creating the space for the panels to be put in place. And then I think the video gets cut off right here. It also has a conveyor belt that's able to remove the spoils from what we call the front of the machine, the header, and a conveyor belt above ground. So it, like I mentioned, it digs, it builds the tunnel wall, and it moves the soil above ground. So this, I mean, it's just from the schematic alone, we can see the tunnel boring machines can really vary in size, and they vary in size and in length. Now, for our project, the project that we need, our tunnel boring machine is 800 feet long, 21 feet wide. So it's quite massive. How do we get this machine underground? There's no way we're going to be able to dig a hole that big. So again, we're looking at a footprint of the Warren facility in Carson. And knowing ahead, I mentioned earlier how this was a multi-year long project. Preparing for this point, we were able to acquire different properties. So we were able to acquire a facility south of our water treatment plant, so that not to interrupt with operations, where we would build the starting point of the tunnel, and that's what we call the shaft site. So you guys can see it right there pointed out. Now, the idea is to drop the machine in pieces in a smaller tunnel in a smaller footprint. So that's what we're seeing right here. This is a video that's showing you the actual building of the access point, the shaft site, that will then be the entrance point right here. And that's when we actually finish the shaft site. just to get the shaft site alone, just to get this hole in here to put the tunnel boring machine in place with its own little mini technological project for many reasons. I'll rewind it here again so you can see. To start, it's not shown here, but this project was actually almost completely underwater. So digging is not an option. What we had to do was use this the hydro mill to be able to carve out, instead of carving out a hole, we were able to carve out sections of the soil and then put our rebar in. And that's how the walls of the tunnel of the shaft site were built in pieces. So that's part one. And I also want to point out right here on the left side, here's the shaft site. Right here, you're able to see our tunnel boring machine was actually in pieces, because that's the trick to it. Our machine is quite long at full length, but it had to arrive in pieces so that it can be dropped into this shaft site in pieces and then assembled underground. I'll show you guys some more pictures on that. Like I mentioned, this project was entirely placed underwater, so the walls of the shaft were built in sections. And then after that, we had to pump all this water out and then put a concrete slab at the bottom so that we could then be able to drain the water out. So we had to use a specialized piece of equipment called a tremie pipe, which is pretty much a funnel that kind of puts the concrete, force of concrete at the bottom and is weighed down so that the concrete doesn't rise to the top. And then after that, we were able to build the bottom part of our shaft, and then we were able to pump the water out. So if you talk about special cool jobs, this is a professional diver that dives in dark water to be able to inspect a concrete slab that's, I don't know, the shaft is 150 feet long, so it's well over 70 feet underwater. So exciting job right there. So our shaft has been built, and now we have to lower our tunnel boring machine in pieces. Just a few facts about our tunnel boring machine. It was assembled in Germany. It was tested. Then it was dismantled. It was shipped over here in pieces. Then it was brought over by trucks. And this is how it arrived piece by piece. So once it was arrived here, then we were able to lower it little by little, piece by piece, and it was being assembled, tested, on the go. Now, if you notice, there's a little bit of a tunnel right here to be able to start. We call that the starter tunnel, because if you picture a shaft, it's just, a solid column going through, but it needs to have a little place to go. So that would have been our starter shaft. And this is the head of the machine that has the carving equipment, this is the mining equipment moving forward. So this was exciting times. This was in 2019, I believe. So now we got our machine underground and we're ready to start digging our tunnel. We have, let's see, so right here. So we started digging our tunnel in November 2021. The project officially started in 2019, but it did take about 2 years to get the shaft and the shaft property ready, and then the access shaft completed, and then the tunnel machine kind of lowered, tested, and then we were able to start digging the tunnel. So what I'm showing you right here is the path that the tunnel boring machine will take and the different milestones that we have achieved and how long we've achieved them from. So let's start with the most obvious question that maybe some of you have is, why is the tunnel in this serpentine pattern? Why is it not a straight shot of the tunnel, like the older tunnel? Well, the answer to that is like I mentioned, this was a multi-year long process. In the environmental design phase of this project, we did take in a lot of community input, and the resounding answer was that they wanted to make sure this tunnel did not stay in public right-of-way, so that it did not go through residences or homes. So with that in mind, the sanitation districts took advantage of the streets, the right-of-way that were available to get to the existing shaft site that we have in Royal Palm Beach, and that's why we have this serpentine kind of pattern. And I believe out of the 7 miles of the tunnel, it only crosses one business parking lot and the very corner of someone's front yard. So we did stick for the most part to the public right away. So talking about milestones, there's different milestones were met for different reasons. We're actually, the beginning of the project actually went quite smoothly. There were different soil conditions that led the tunnel boring machine to go faster, but then it kind of slowed down, and I'm going to talk about that later. There's a very, very good reason for that. But currently we hit mile 5 in January 2025. So that's where we still are. So we've completed 5 out of 7 miles. We can see the end in sight. And for a project that's been a multi-year, at least 2 decades worth of, a lot of hard work from our planning department, our engineering, our construction department. It's very satisfying to see that the end is almost here. So now I want to show you guys a video that kind of, how does it look like? What does our tunnel alignment look like? So I hope you guys enjoy this video. I will try to narrate it really fast, but let's share the screen. So we start off our shafts, our tunnel started off on our side. We did go down Figueroa, if you're familiar with the area. We did go underneath the freeway. We went underneath the golf courses. Most people didn't even know we were there. Also, if you're local to the area, we have the lake right there, Lake Machado. We went underneath there as well beneath the project's mostly already underwater. We went down Gaffey Street, and if this is the main, it's not a residential area, it's mostly a commercial avenue, commercial street. Again, we stopped there, continuing our way down, past the Home Depot if you're local to it. And then this is when we take the wide turn. This is the private business. So this is the parking lot of Target. That's where we have to kind of go underneath them. We did have to work with our property planning group to get an easement. Now you see we're going through homes, but again, this is a major street. So most homes we were not even aware that we were there. Again, this is very satisfying because we're trying to be the least disruptive to the community. Now we are turning south on Western Avenue. And again, we're underneath a major street, well underground. We'll cover that in a little bit. And as we get further down to Western Avenue, if you look to the top right corner, you can kind of see the beach is kind of close by. So right now we're very close to where mile 7 is. So I hope you enjoyed that. It's a really cool recap of the last 4 years of our project. But now we're going to cover about building the wall. So I mentioned that the tunnel boring machine does quite a few things. We see how it carved the soil. Now, how does it build the walls? Well, the walls themselves are their own engineering project. So we do have a manufacturing place where we actually build the walls. This is where it's an automated manual process where you're able to create like the molds for the concrete. So we can see here, and then they're obviously baked, secured, to make sure that each segment is produced to the highest quality. Fun fact about the projects: the panels themselves, they all have their unique thickness and configuration, so that when they're able to have curves, they're just rearranged differently. So that's marvelous feat on its own. And this is what I like to call a little tunnel farm, because the tunnels are actually manufactured in Palmdale, in the Italy area, so not at the project site, and they're actually inspected on site in Palmdale, and then they're trucked over to the construction site in Carson. So that's well about a 2-hour drive away. Once they're here on site, they're re-inspected again, and then they're lowered into the ground. That's why you see them lifted up in the crane, so that the tunnel boring machine can build it. So this is what we're seeing right here: is the panels being lifted. We're using the crane, being lowered down the shaft, and we actually have a little vehicle that's able to transport all the equipment to the front of the tunnel, the working side, the front of the tunnel machine. So now I'd like to cover a little bit on what does it look like geology-wise? What is the geology that it's digging underneath? So this is the depth of our project. And as we can see, when we started on our shack site in Carson, this is where we started, so it will be the left side on Figueroa Street. We were 70 feet deep, which is still pretty deep. And as we moved forward towards the end, which would be the right side, Royal Palms Beach, we see that the topography changes, which means that the tunnel is now digging way deeper than the from the surface. Now there's a reason for that. In the beginning part of the project, this is the soft shell. The drilling was pretty fast. The mining was pretty fast. But as we hit the Palos Verdes Peninsula, now we're hitting bedrock. So now it takes a while. It was a learning to operate the machine a little slower. Obviously it's bedrock, so it has to go up. It's kind of slowed us down, but that's okay. We were expecting that as well. So just to put things into perspective, we are so deep, almost more than 300 feet deep, that we are actually way deeper than the Statue of Liberty. So we did a little math in there. So this is way down there. Again, people don't even know that we are there. And that's pretty far down. That's beyond any vegetation or any utilities. Those are usually within probably the first 50 feet, I want to say. Okay, So you may be curious to know, what does the inside of the tunnel look like? On the right, on the left, we have a picture that kind of shows what the inside of the tunnel is. And what you're seeing are the walls. You can see they kind of look like Legos that are interconnected. Again, I mentioned how the walls of the tunnel are assembled piece by piece. And then this inside this machine, this is actually part of the tunnel boring machine that we call the trailing gear. And it actually carries all the cables and for the supporting equipment for the boring machine in the front. So our tunnel boring machine, believe it or not, it's electrically powered. We actually have a substation up at the surface, and we have a really long power cord that has to move its way across with the front as the machine moves forward. It also carries ventilation lines, it carries the slurry lines, communication lines. So this trailing gear has to grow and move along with the tunnel boring machine. That's why our tunnel boring machine at full size is 800 feet long. So that's a good picture of that. Now, right here on the right, let's see, on the right, it's a little video that kind of shows, some of the equipment that's in there, but more importantly, kind of shows you what the tunnel boring machine looks like if we were to walk our way towards the front. And this is only the first mile, but it really looks the same after that. So on the top, we also have air, communications, water, all those good things. And obviously the video is kind of sped up, but this is also the way our crews are kind of moved to the front of the building, equipment being sent out to the building. And I know I sped it up a little bit for your convenience, but right now it's taking about a 45-minute drive to go from the shaft side to the front of the where the tunnel's actively mined. And let's say we're coming on the way out. This is the front of the vehicle. So sorry, the bottom of the shaft, the beginning of the tunnel, and this is kind of how that machine looks like, the rubber gantry crane, rubber tire vehicle. It's at the bottom of the site. Okay, so for our friends, if you're local to the area, I may have mentioned earlier how we have some dots on Avenue outreach. So for the most part, the tunneling operation went through larger streets, commercial streets. Even when it did go through a residential area, it was it's a pretty wide avenue. But this Dodson part right here is a little different only because it's a smaller residential area. And we are mindful of that it's a smaller street. So it's only a 2-lane street. But as we can see here, if we had followed the length, the main street, which is Western Avenue, if the street just naturally like has this, kind of curves around, it was more efficient for us to finish through Dodson, cut to a smaller street, which is still a street. But we did have some not sensitivity, but we want to be courteous to our neighbors. So we did some special outreach to our neighbors in Dodson Street. We did let them know that they were going to start tunneling, which we did just last week. But we're so way in, 350 feet deep underground. They're not going to feel anything from our end. So how does it end? Are we going to keep building our tunnel forever? We mentioned that our tunnel ends at Royal Palms Beach. So let's see what that looks like. If you're not familiar with the area, this is Royal Palms Beach, which is in San Pedro, local to the area. So this would be the end point of the tunnel. Now I'm going to pause it here. Oh, the video actually ends there. So you're going to say, Maria, where does your tunnel end there? I don't see what's going on. All I see is the fancy house at the top. Well, if you notice this fenced in area that's right here, it's fenced in because that's where we actually have our infrastructure that takes the existing 2 tunnels and has a series of outfalls that release the water into the ocean, but that's all done underground. So this is the input for a tunnel. We're going to have to connect our new tunnel here. So let's see what that looks like. Sorry, I'll just go back. Let's see. Right here. So as we're driving down, we see this tunnel right here, and then we see this little mysterious hatch right here. That's the hatch that we're going to see. And what I'm going to do right here is just going to play the video just to show you what's underground. That's really why this property is fenced off. So let's see if I can play the video. All right, so this would be confined space entry, which means not just anybody can go in. You have to have some sensors. This facility is normally closed to the public, obviously. But there's really no quite need to attend this, just regularly monitoring. So this is what our friend here is doing, some checking the air, and then we get the clearance to go ahead. This was my former colleague, Glenn Acosta, who used to be in charge of this project about 2 years ago. And this is my first time that I got to see to visit the manifold structure, which is what we call it. So forgive the nature of the video. But underground in here, we have we have these pumps that take the water from the two tunnels. Tunnels carry clean water again, and they rearrange it to 4 outfalls. The difference between the tunnel and the outfall is the tunnel carries the clean water underground, but the outfalls carry the clean water underneath the water in the beach along the ocean floor. And then at the end of these outfalls, they run about a mile and a half underwater. The water is released slowly into the ocean and it gets blended in. So it's not like a waterfall. It's slowly introduced into the system. So this is a possible construction footprint. So we see a lot here. Let me walk you through it. I just want to show you guys what we are planning actually currently right now. So starting with the white lines on the top, these are our 2 existing tunnels. You can see them, they're coming down right here. And this is our manifold in white, which is what you see. Knowing that we have a new tunnel that we're building that we still have to connect to, that will be the yellow line that's coming in from the right side. And that also means that we have to expand to our manifold, which is what we're showing right here in yellow. Also showing in white right here, we're showing the existing outfalls that are doing there. So we have quite a lot of work to do in this area. This alone is going to take about 2 years. This alone is its own project with its own engineering demands. The first one that we're showing here is space. It's a very small space for such a large project. So again, knowing that this project was coming eventually, we were able to acquire lots of property, which is great, except for these are hills and bluffs, so not too good maybe. But we have the space there. So we do have to kind of encroach a little bit into the parking lot for this beach, but we want to maintain vehicle access, which is what you're showing here. So this is kind of unique that we have to make the most of what we can with this construction in this tiny footprint. And you guys may not know, but this is our possible simulation of what this construction could look like once we get there. Again, we're trying to separate our area from the construction area from the guests that enjoy the beach regularly. But this is like real life examples of us working with the community. Again, we want to make sure everybody's safe, but that our site is secure for our construction of our project. And then we kind of put like a visual barrier, not just a fence, and a noise barrier, because it will get a little noisy there. So project timeline. This is the chance when we can see the many years spent on this project. We started the planning and outreach process in 2006. Our board formally approved this in 2012. So that kind of marked the end of the planning phase. This is the time that we were collecting input from the community. And once the project was approved, it moved into the design phase. It was there for a solid 5 years. There was quite a lot of construction and engineering and design itself. So the tunnel design was finally completed in 2017. Very shortly after that, the project was awarded construction, and that's when we were able to start construction in 2019. By construction, remember, I mean getting the site ready, getting the shaft site ready so we can accept the TBM, assembling the TBM, and testing the tunnel boring machine. And then we were able to start tunneling in 2021. So what do we have left to do? Well, in order for us to be able to finish the tunnel and receive it at the end, Royal Palm Beach, where I'm just showing you the slides, we need to start doing some work ahead of time to make sure that we have the kind of like a mini shaft site to be able to get to the machine, because when the machine gets to Royal Palm Beach, it will be 30 feet below ground. So we need to do some work. That's expected to start in the summer, late summer this year. Later in the year, probably in the winter, that's when we expect the tunneling to end. So obviously we have to make sure we have a place for the tunnel machine to be received. And then I mentioned it will be another 4 years in this case to be able to finish the work at Royal Palms. And then this project will be done and it will be ready to serve LA County for many years, at least 100 to come. So with that, I thank you guys for your time and I'm ready to answer questions, Nick.
All right, excellent. Thank you, Maria. Very good comprehensive presentation. All right, first question. For the design portion of this, what kind of seismic analysis was done?
Oh, there was quite a lot, believe me, because part of the seismic considerations was that they had to pretty much see which faults were going through. I do know that there were 3 fault lines, but only one was active. So along the 7-mile parts of the tunnel, the tunnel is reinforced for seismic consideration in 3 different spots. One of which is not related to an earthquake. It's actually because it goes underneath the freeway, that 110 freeway that I mentioned. But there was a study, I believe, anticipating for up to 7 magnitude earthquake. That was the estimate, the model that we based it on.
Why is water discharged into the ocean rather than into a freshwater system?
Okay, that was not the question I was expecting, but there's a good answer for that. So the water is cleaned and discharged to the ocean because it's the largest body of water that's there. I know we passed the lake, but the ocean, that was the place that it's originally being discharged to. However, with the pure water project that I mentioned earlier, the plan is to take that water and recycle it. So it will be advanced water treatment and recycled for use and sent to other water basins in the not in Carson, but further up for other communities to use, and also Carson. So the water will be discharged less into the ocean and more reused and put into groundwater aquifers that are upstream. So there's a little bit, not all going to get discharged to the ocean. Next question.
Were there any intermediate vertical shafts for ventilation or soil removal? And if so, and with the shaft alignment being largely in public roads, how many and where were they placed? And if not, what challenges were associated with having no intermediate shafts?
Yes, so that's a good question. There were no intermediate shafts because the community said they didn't want they said the Swiss cheese analogy. They didn't want multiple shaft sites along the access point, along the tunnel alignment. So that's why we made the commitment to have the Carson shaft and the Royal Palm shaft. The Carson shaft is the main entrance and exit point for all the equipment, even at Royal Palm Street once the project is done. Only the shield, which is the orange part of the tunnel boring machine, will be removed there. Everything else has to backtrack and come out of Carson. And the other advantage to that is the shaft in Carson is within our property, whereas the Royal Palm shaft is, public. I mean, it's our property, but we're using some of the public land there. So we're very mindful of that. To answer that, also anticipating that we didn't have intermediate shafts, we do have what we call safe havens, where there were pre-drilled grout stations where the tunnel machine could go and be pressurized, and we could do testing of the equipment and the gears. And those were actually just so they were pretty much they were drilled cavities underground filled with grout, and that's where our tunnel machine ended. So we were able to do maintenance either ahead of the arriving at the bedrock or after the water, just to test things, but it wasn't a shaft site.
How does the TBM make turns underground? It seems like it has no flexibility.
It is actually, I don't have that slide. Let me see if I can find it here, but it is actually articulated. So meaning that it has joints that is able to, kind of like a toy, you're able to bend the little arms to be able to move it. So the actual tunnel boring machine, it sews like one solid piece, but it's actually intercalated. So that's why it's able to make those wide turns, and it's able to rearrange itself to be able to meet those turns. So when it does turn, it makes those like wide semi-turns. It can make a sharp turn, but it can make a wide turns like we saw in the video.
What were the mitigation measures for the tunnel segment crossing the active fault?
I mentioned that earlier. So they will have kind of like a separate steel pipe underneath the tunnels of the wall, and connecting the steel walls to the tunnel wall is compressible grout that's able to absorb the energy, the shocks from the earthquake. And those are, think of them as sleeves underneath the tunnel. Those are about 300 length. They can vary in length, so they're anywhere between 300 to 500 feet long inside the tunnel.
Someone wants a reminder on how deep in the ground you said the tunnel is.
It can vary depending on where on the alignment. It started around 40 to 70 feet deep. Currently, it's around 350 feet wide where it's drilling now. By the time the project ends, it will be 30 feet below ground.
How will you get the boring machine out once the project is finished?
So they're going to actually remove the shield, which is the front part that actually does the carving, that has the smaller footprint. That's actually going to come out of Royal Palms. The rest is going to literally drive in reverse, and will probably be unassembled just the way it was assembled. It will be unassembled and lifted up the shaft site in Carson.
At what speed does the tunnel boring machine go?
Very slow. We usually drill about 50 feet a day, so it's not too fast. Each segment that it drills, it only goes in increments of 5 feet. So it moves 5 feet at a time. It's almost a whole day could be 50 feet.
Was the ground surface monitored for deformation during the tunneling, and what instruments were used if so?
Oh, excuse me, can you repeat it again?
Sure. What was the ground surface monitored for deformation during the tunneling, and what instruments are being used for that if so?
There were quite a few instruments. There were instruments placed within the tunnel boring machine. There were sensors that were put along the depth of the tunnel. There were instruments that were put on the utilities, any underground utilities. There were sensors that were put on the surface, and then there also had sensors that were placed on structures. So everywhere along the length they were placed. However, that was mostly when it was in the shallow part of the soil. When it was bedrock, we assumed it was bedrock. So they're only on the bond on the along the surface of the alignment.
Okay. Someone's asking about the tunnel boring for turns again, asking how sharp of turns it can make. I think you mentioned that briefly, but I don't know if you want to reiterate that.
I don't have numbers, but I just know it's a pretty wide turn.
Okay. Where were the tunnels placed?
The what?
The tunnel spoils, the spoils from the digging,
Oh,
the
the spoils
boring.
for the digging. Yes, so that's actually for the contractor. Our contractor is Dragados. That's for them to decide. I did hear in the beginning it went to a quarry in Irwindale, so it was being sent to a quarry. At some point in time, maybe the quarry was topped out. It did make it to a landfill, but it is not in our contract to dictate how the spoils are done. It is for the contractor to decide how to use them or what to do with them.
Okay. Were the properties free of utilities? Obviously, you've answered that a little bit, so you can talk about extensiveness, or did they have to be relocated in some cases to and supported prior to starting the shafts?
If there were any utilities,
Yeah, they're asking about what was done for the existing utilities. Did they have to be relocated, any of them, or were any of them having to be re-supported during prior to the
no,
process?
when the tunnel started, it was already 150 feet underground. So it was pretty deep, and then it went 70. So that was well below any utility.
Okay.
They did check for that.
What were the shaft diameters and thickness of slurry walls?
The shaft diameter was around 50 to 60 feet long, 150 feet wide. And the walls of the segments, I don't recall off the top of my head for the circumference. I don't know. I could probably follow up with that.
Okay. Anticipated cost. So we put 700 million. Is that still on track for 700 million, or what are we looking at for anticipated total cost?
It's probably going to fluctuate a little bit up, but the plan for this is that we have obviously our reserves, and then also knowing that we've been planning for this project for a long time, we were kind of um, using some of our reserves to cover this project, and we're also applying for loans and bonds, state bonds, to help lower the cost. At the end, once this project is fully financed, because it does serve 5 million people, it comes out to a $5 increase in the sewer fees. So the power of the community, the large service area helps cover the cost.
Let's follow up on the fault crossing mitigation. What is the diameter of the steel casing?
The diameter, well, it would be something similar to the inner diameter of the shaft site. So the outer diameter of the tunnel is 21 feet, but the inside, once you count the thickness of the walls, is 18 feet. So the tunnel itself is, I'm sorry, the steel liner is 18 feet. I don't know how thick it is. That's probably maybe what he's asking. I don't know that. I have to
Okay.
follow up with that.
Yeah, let us know if there's additional follow-up on that question. Did you run into any environmentally sensitive soils or methane pockets during drilling of the tunnel?
That's a good question. So Carson, everybody knows, or a lot of people know, they have a lot of utilities, a lot of oil, a lot of refineries and stuff. So there were some considerations for that. Because of that, actually, I think you can categorize the airspace underneath. So the machine is actually categorized as potentially gassy. So you wouldn't even be able to have a cell phone. It wasn't until they moved further along that they were able to remove that designation. And I mean, it changed something in the health and safety operations of the system. But that was the only area to my concern that affected the drilling.
What about groundwater and surface water? Is that being encountered during drilling?
Yes, the whole project is underneath groundwater, and that means that whenever we have to, well, first of all, the front part of the chamber is pressurized. If we wanted to change the cutters, kind of the actual gears that are actually cutting the soil, we have to move into an area, you're exposed to water and change the water underground. So it's actually one of the unique aspects to this project. It's all underwater and it's carrying water, going to more water.
Okay. Unless someone beats me to it as we close out and thank you, that concludes the Q&A. So thank you, Maria, for a very good presentation, kept everyone's attention. And we will send out PDHs to those wanting them. We'll send out those certificates for anyone who's on for a half hour today. Again, thank you to ACE also for co-sponsoring this. Go ahead, Maria.
No, I was going to say if there were any questions that I didn't answer, or you would like more information, we do have a project website which I can put on the chat, or if not, they can forward it to you, and then you make their way to me because
Sure, yeah,
I'd like
let's
to
just put that in the chat very quickly here.
yeah. All right. So there's
So,
actually quite a few Clearwater projects. So actually, the chat can only go to the post and panelists. So maybe you can.
oh, that's fine. I'll post it to
You'll
everyone
put it
if
up.
you,
Okay.
yeah, if you post it, and I'll forward it to everyone here. So if you're looking for the website, I will be posting it here in just a second. And then if you have questions, my email, of course, if you need any other information, will be in the chat here.
So I put it. Let me give it to you. That's the project website.
Okay. I will put the project website right now. So if anyone wants to do additional research, project website is now in the chat.
Thank
I'll
you.
give just a second for everyone to get that. And yes, thank you, Maria. Everyone have a good evening, rest of your afternoon. Talk soon.
Thank you so much, everybody. Have a great day.